find the distance between the 2 points, -4, 6, and -2, 8. We have here 2 points on the Cartesian plane, x-coordinate -4, say right about, we'll put it there, and y-coordinate 6, I'll put it there. Okay, so that's -4, 6. And then we have -2, 8, -2 somewhere between 0 and -4, so right around there. 8 somewhere above 6. Not drawing this to scale. We don't need a good scale. So there's 2 points, -4, 6 and -2, 8. And I want to know what this distance is between the two. Right, that length right there. We could dig out the distance formula, compute things, but the distance formula is a little bit of a messy formula. It's not as simple and as nice as, say, an area of a triangle or area of a rectangle or all these easy formulas to memorize. There's, some x's and y's and other x's and other y's in this distance formula. So why bother memorizing it? Because it's very easy to just come up with the right answer by using other methods. That other method is to just go ahead and drop a vertical line down from this point, draw a horizontal line across from that point, and now we have here a right triangle. And with the right triangle, we have the Pythagorean theorem. Right? The length of the hypotenuse squared is equal to the sum of the squares of the other two sides. Right? So if I was able to find that distance and to find that distance, I could solve for the hypotenuse distance relatively easily. And lucky for us, we can find these two distances pretty quickly. After all, this distance here is the distance between these 2 points, and I know the y values at both of these spots. Right? The y value here is 8. The y value here is 6. How far away is 8 from 6? Well, we do subtraction. 8 minus 6, 2. Right? So that distance is 2. Same thing on the x-coordinates. To find this distance here, I just look at my 2 x-coordinates that are involved, -4 and -2, and I say, how far apart are -4 and -2? We could do a subtraction problem, -4, or take the big one first, -2 minus -4, and come up with an answer, or we could just, say, oh, I know how to find the distance between these things. It's just distance, again, of 2. So, I have my 2 side lengths. Let's solve for the hypotenuse. Why don't I call it length C? So Pythagorean theorem tells me that the hypotenuse squared is equal to one of the side lengths squared, 2 squared, plus the other side length squared, another 2 squared. And now I can do some arithmetic. 2 squared is 4, plus another 2 squared is another 4. So we get 8. So C squared equals 8. So C must be equal to one of the square roots of 8. It could be equal to the other one, at least this equation, but we're dealing with distances, so that's not the solution to this equation that we want to use. We want to use the positive solution. So C equals square root of 8. If you wanted to, you could go ahead and realize that 8 is 2 squared times 2, and then you could take this 2 squared bit, pull it outside of the square root. And when it comes outside of the square root, we lose the squared. It just becomes a 2. We have that root 2 sitting on the inside still. So the hypotenuse has length 2 times root 2. And we're done. We have the distance. We didn't need to dig out the distance formula. If we had, the distance formula involves things like the difference of my y values. So this 8 minus 6, which is that 2. It involves the difference of my x values. So this -2 minus a -4, which is, again, equal to this side length 2. And then what does this distance formula do? Well, it squares this thing, and it squares that thing. And so we're dealing with a 2 squared and a 2 squared, and then the distance formula goes ahead and adds them, just like we did here. And then the distance formula goes ahead and says, well, take a square root of that, just like we did there. So we did the distance formula. We refigured out the distance formula, but we didn't have to remember what the distance formula was. We just had to remember this simple old fact from Pythagoras 2,000 years ago in the Greeks, right? A squared plus b squared equals c squared when we have a right triangle. Draw the right triangle, solve, and we're done.